So, what is the best way to protect our web applications? Of course, security starts with protected routes, and these are endpoints that require user to be authenticated before accessing sensitive data. For instance, test data should only be accessible to the user who owns it. Without protection, anyone can read modified data, find out your password, and it's a big vulnerability. In Express, we protect routes using middleware. Middleware runs before the route handler and decides whether the request can continue. And in our application, here's the example of it. So this checks if the user is logged in, and if not, it stops the request with a 401 error. Otherwise, it calls next to continue. We apply middleware only to protected routes, not public ones like login. So when we go to our app.js, we can see it here. Middleware, auth, routes, task routes. That's how it works. So protected routes require authentication. For example, in our case for tasks or users, public routes, open access for registration and for login. How is data validation happens? The one that protects our application from malicious input. Validations prevents attacks like SQL injections, that's malicious queries hidden in input, or XSS, cross-site scripting, scripts injected into your app. We use Joy for that, and should be in our validation. So here we use Joy for this purpose, and here is a piece of code that helps us to create a strong password. For instance, for the email, there are certain requirements. It must be valid format, it must have lowercase, and it has to be trimmed. For a name, let's say, it also has to be a string with a minimum of 3 characters and maximum of 30 characters, and it is required. For password, there are a lot more requirements, so it should include lowercase, uppercase, numbers, special characters. So in this case, it will be more secured. If we go to test schemas.js, we'll see this example also using Joy, and title in this case is required. We need clean string also with 3 to 30 characters. And for is complete, it should be a Boolean, and for now it defaults to false. Validation ensures only safe, well-formed data entering the system. And finally, when we talk about passwords and their security, in our application, we'll go to user controller file. So we should never store passwords in plain text. If database is compromised, attackers can gain access to the account. And oftentimes we know users reuse passwords. That's how they can get access to it. So instead, we store a hash of the password. And hashing is only one way. It cannot be reversed and used for verification only. Encryption, by contrast, is reversible. We also use salt. That's a random, here we have examples of that. It's a random data added to each password before hashing. And this prevents rainbow table attacks where attackers use pre-computed hashes to crack passwords. So here is our example. So the key principles are to always use trusted algorithms like script, never inventing our own cryptography, and always including a unique salt for password.